Okay, taking a look at your test review, I thought I'd go through some of the things on those. So 1 through 4, when you're looking at end behavior, first of all, you want to make sure that the polynomial is in descending power of degree. The second thing you want to check for is the sign of the leading term will determine the right behavior, what's happening on the right of that function. And then to figure out what's happening on the left, you look at the power. If the power is even, it's going to be the same as the right. If it's odd, it's going to be opposite the right. So let's take a look at number 1. Number 1 says f of x equals 2x cubed plus 9x squared minus 3x plus 8. It is in descending power, so really all we're keying in on is this. So we got to figure out what is it doing on the right and what is it doing on the left. On the right, this first leading term is positive, so that means it's going up on the right. The power is odd, which means the left has to be doing the opposite. So on the left, this would be going opposite of up would be down. So you're looking for something that's down on the left and up on the right. So your answer is B. Number 2, f of x equals negative 1/5 x cubed plus 2x squared plus 4x minus 4. Again, we're only looking at this first term. So on the right, we look at the sign of the first number. It's a negative. That means on the right it's going down. The power is again odd, which means the opposite. So if it's down on the right, the opposite of that would be up on the left. So you're looking for something that goes like this, down on the right, up on the left. Number 3. Oh, that answer then would be A. Number 3. F of x equals 3.6 x to the fourth plus 5x squared plus x minus 9. So again, we're only looking at this. The right is determined by the the sign on the front, which is positive, so that'd be up. The left is determined by the power. Is it even or odd? This power is 4, which is even, so that's the same thing. So it'd also be up on the left. So we're looking at something that's up on the left and up on the right, which would make the answer to number 3, D. And number 4, last one like this, you get f of x equals, again it is in descending power, negative x to the 6th plus 8x to the 5th minus x squared minus 5x plus 9. The leading term, this is what we're looking at on the right. Since that's a negative, it'd be going down. And for the left, since that power is even, it's be getting the same thing. So this is going to be down on both sides, which would make the answer C. All right, for number 5, let me scroll through. I'll come back to these. Number 5, we have x plus 4 squared times x minus 1. It's already been factored. So what we've got to do is we've got to set those factors equal to 0. So I'm going to put x plus 4 equal to 0. Subtract 4 from both sides, and I get x equals negative 4, and that would have a multiplicity of 2 because it's to the second power. That means that factor is used twice, so that has a multiplicity of 2. And set x minus 1 equal to 0, that gives me x is equal to 1, and that would have a multiplicity of 1 because it's just to the first power. So my answer is going to be that negative 4 is a 0 with a multiplicity of 2, and 1 is a 0 with a multiplicity of 1, so that would be C. Number 6. Again, it's already factored. You don't have to worry about the 2 when you're trying to solve for zeros because there's no x attached to it. So if there was an x up here, then I'd want to set it equal to 0. But if there's not an x, you don't have to worry about that. So I would set this factor, x plus 9 equal to 0, and solve it. And I get x is negative 9. That has a multiplicity of 2. See the power? And then x minus 9 equal to 0. And solve that, you get x equals 9. That has a multiplicity of 3 because of that power. So my answer is negative 9 with a multiplicity of 2 and positive 9 with a multiplicity of 3, which would be A. Number 7. All right, this one's also already factored. I do have to worry about the x squared that's in the front because the negative 4x squared, because there's an x there. You can write down negative 4 with the x squared. If you divide by negative 4, you're going to end up with x squared equals 0. So you can either write it down or leave it off. It doesn't matter. So if x squared equals 0, that gives me 0. X equals 0. That has a multiplicity of 2 because of the x squared. If it was just an x, it'd have a multiplicity of 1. And then set x minus 7 equal to 0, solve that, you get x is 7. That also has a multiplicity of 1. Set x plus 1 equal to 0, solve that, you get x is equal to negative 1, and that has a multiplicity of 3. Number 8. Okay, x squared minus 1 squared is x squared minus 1 times x squared minus 1. So set both of these equal to 0. If you have x squared minus 1 equals 0, let me erase this and show you what you do to get here. If you have x squared minus 1 equals 0, then if you add 1 to both sides, you'd get x squared equals 1, and then you'd square root both sides. Remember, there's a positive and a negative square root. So that'd be positive and negative. Square root of 1 is 1. And if the solution over here is positive and negative 1, then the solution over here, which is the exact same equation, would also be positive and negative 1. So you end up with 2 positive ones and 2 negative ones. So 1 multiplicity of 2 and negative 1 multiplicity of 2. So the answer number 8 is C. Number 9. You got x squared plus 11x plus 24 squared. So that's like having the same factor twice. X squared plus 11x plus 24 can factor to x plus 8, x plus 3. Because 8 times 3 is 24, and 8 plus 3 gives you that middle term of 11. So I have x plus 8 and x plus 3, and x plus 8 and x plus 3. So when you solve those, if you set x plus 8 equal to 0 and solve it, you get x is negative 8. And if you solve x plus 3 equals 0, solve that, you get x is negative 3. So you get negative 8 twice and negative 3 twice. So my answer to number 9 is D. Number 10. Okay, this has to be factored. I saw some people trying to use the quadratic formula, but it's not a quadratic equation, so you can't use the quadratic formula. So you've got to factor. So to get x to the fourth, it'd be x squared and x squared. It'd be minus 16 and minus 2. So to add to negative 18 and then multiply to positive 32, set them both equal to 0. X squared minus 16 equals 0. Solve that. You get x squared equals 16. Take the square root, positive negative 4. X squared minus 2 equals 0. Add 2 and square root. You get positive and negative square root of 2. So your answers are going to be positive 4 and negative 4, positive square root of 2, and negative square root of 2. So in number 10, that would be B. All of those have a multiplicity of 1. I'm going to keep going, see if I can get to 11 and 12. 11 is a lot like 10. It factors, again, it's to the fourth power, no using quadratic formula. So it's x squared and x squared. Two numbers that multiply to give you 8 and add to negative 6 are negative 4 and negative 2. So set each of these factors equal to 0 and solve them. You'll get positive and negative the square root of 4, which is 2, and positive negative the square root of 2, which you can't simplify. So the answer to D is positive 2 and negative 2, and positive square root of 2 and negative square root of 2, which is going to be 11 would be D. 12 has 4 terms, and what we want to look for is when a function has 4 terms, you want to see if you can factor by grouping. So you divide it down the middle. Out of the first 2x cubed plus x squared, I can take a GCF of x squared out, and that would leave me 2x plus 1. Now the last 2, I can take out a negative 9, and that would leave me with 2x plus 1. Hopefully, if you've done it correctly, these two should match, and that's one of your factors. So 2x plus 1 times is what's in front is the other factor, x squared minus 9. Because if I'm doing x squared times 2x plus 1 and minus 9 times 2x plus 1, it's like doing x squared minus 9 times 2x plus 1. Solve 2x plus 1 equals 0, you get negative 1/2. Solve x squared minus 9 equals 0, take the square root, you get positive and negative 3. So it's negative 1/2, positive 3, and negative 3, all with a multiplicity of 1. So that's B. All right, I'm going to pause this right here and pick up with number 13.